Hi, and welcome to Quick Add Math on logarithmic and exponential functions. Let's begin with logarithm with base 10. Just like minus is the inverse of plus, and so on, logarithm is the inverse of exponents. Mathematically, x is equal to log y with a base z is the inverse of y being equal to z to the power of x. In a base 10 logarithm, x equals log y to the base 10 is the inverse of y being equal to 10 to the power of x. Knowing previously that when x is equal to 3, y is equals to 10 to the power of 3, which is 1000, log 1000 to the base of 10 is 3. The base 10 logarithm can be simplified as lg 1000 equals to 3 or log 1000 equals 3. Without a calculator, we should know that the log of 100 is 2, the log of 10 is 1, the log of 1 is 0, the log of 0.1 is minus 1, the log of 0.01 is minus 2, and the log of 0.001 being minus 3 when it is a base 10. From what we should know, we shall expand what we know to stating that log a to base a is 1, any log 1 is 0, and log a to the power of b is the same as the product of b and log a. Also, b is equal to a to the power of log b base a. Tutorial question 1. Solve the following. For number 1, it converts to x being equal to 10 to the power of 0.3, which equates to 1.995 correct to 3 decimal places. For number 2, the log will convert to an exponent of x being equal to 10 to the power of minus 0.3, which comes to 0.501 correct to 3 decimal places. Tutorial question 2. Solve the following. For number 1, 81 can be converted to 3 to the power of 4, and by the rules of log, this is the product of 4 and log 3 with the base 3. With log 3 to the base 3 being equal to 1, this can be further simplified to being just equal to 4. For number 2, 8 root 2 is equal to 2 to the power of 702, enabling the log to simplify to just 7 over 2 or 3.5. Tutorial question 3. Solve the following equation. The first step involves changing its log to base 3 to an exponent, making the equation into log x with base 2 being equals to 3 to the power 1, which is 3. You would perform this conversion again, enabling x to be equal to 2 to the power 3, which is 8. Here are two more laws of logarithm, where log of xy with base a being equal to log of x with base a plus log of y with base a. Likewise, the log of x over y with base a is equal to log of x with base a minus log of y with base a. Tutorial question 4. Write as a single logarithm log of 5 minus 2. For starters, 2 can be restated as 2 log of 10, which is equal to log of 10 square or log of 100. By applying the laws of logarithm, this is equal to log of 5 over 100 or log of 0.05. Tutorial question 5. Simplify the log-based fraction. with 32 being 2 to the power of 5 and 0.125 being 2 to the power of minus 3. We could simplify the fraction to being minus 5 over 3. Tutorial question 6. Solve the equation involving log x. By making the product of 2 and log x with base 4 being log of x squared of base 4 and making 1 being equal to log 4 base 4, we could use the laws of logarithm to make log of x squared over x plus 3 base 4 being equal to log of 4 base 4. This allows x squared over x plus 3 to be equal to 4, which we could turn into a quadratic equation to solve for its x. Tutorial question 7. Solve the equation involving log with base of x. By first converting the product of 2 log 3 with base x to being log of 3 to the power of 2 with base x, which comes to log 9 with base x, also making 2 being equal to the product of 2 and log x with base x, which in turn is log x squared with base x. We can use the laws of logarithm to solve for x. Next, we shall look at how we could convert the base of a logarithm. In this case, log b with base a can always be equated to with log b with base c divided by log a with base c. One last but important note on logarithm is natural logarithm. It has a unique base e, with e taking on the value of 2.718 when rounded to 3 decimal points. This unique irrational number will be expanded in future chapters. And for now, we need to know that y equals log x with base e can also be expressed as y equals ln x. And x is equals to e to the power of y when the log is converted to its exponent form. Tutorial question 8. Solve the given equation. With the two logs being with different base, we will convert that with a base value that's higher to equal that to the base value that's lower. In this case, log x with base 4 can be converted to log x with base 2 being divided by log 4 with base 2. This allows us to solve this portion of the expression as being equal to log x with base 2 divided by 2. And by applying the simple subtraction, it allows us to get to the product of 9 log x with base 2 being equals to 6. By converting this to its exponential form, we could then solve for x being equals to 2 to the power of 2 over 3. Tutorial question 9. Solve the given equation. Same applies. You convert the log to its exponent form and solve for x, with e being equal to 2.718. Tutorial question 10. The temperature for a cup of brewed coffee over time has the following formula, where the small t is measured in seconds and the capital T is in degrees Celsius. 1. What is the starting temperature? The starting temperature is at when t equals 0. This allows the capital T to come to 80 degrees Celsius. 2. What is its temperature after 10 seconds? By embedding the small t as being equal to 10 into the formula, the capital T will come to 70.0 degrees Celsius. 3. How long does it take for the temperature to reach 50 degrees Celsius? This can be done by first expressing the formula as being equal to 50, then simplify it in the form of its exponent. Next, you will convert this exponent to being its log form and solve for t from there. That's all for log and exponent functions. If you found this beneficial, do look out for our other KT tutorial videos.